there are laws that govern chemical reactions, right? So scientists in the past have worked on chemical reactions, many have studied it, and then they came up with some laws that is really relevant till today. And that's what governs mostly how to balance chemical reactions and do some calculation in the amount of products and all that we get at the end of the day. So let's look at these laws. The very first one is the law of conservation of mass. The law of conservation of mass says that in a chemical reaction, the total mass of the reactant, right, that's what you are missing, is equal to the total mass of the product. So we say reactants mix to give you products. So the total amount of element, compound, the total mass that you get there is equal to the total mass of all products that you get at the end of the day. So whatever you mix, the mass of whatever, the total mass of everything that you mix together, right, will be equal to the total mass of everything that you get at the end of the day after doing the mixture or whatever, right? The common sense, right? That's what he said. Or another way of saying is that in a chemical reaction, matter cannot be created or destroyed. Whatever you have is what you are going to have at the end of the day. Basically that. Yeah. So we'll be using this law mostly in doing most of the balancing of equations. So at least know this law. This is the very fundamental one that helps in balancing chemical reactions. So yeah, we will be working on this one moving forward in the subsequent videos. The next one is the law of definite proportion. It says that a chemical compound always contains the same proportion of elements by mass, regardless of its source or method of preparation. So we all know water, right? Water is H2O, right? Water is H2O. So you can see that there are 2 hydrogen and 1 oxygen. So we all know the element that we know here, the compound we know here is H2O, that's water. And then water needs to come in the form H2O1. The oxygen should be 1 and hydrogen should be 2. So a chemical compound always contains the same proportion. So we cannot have this thing like H4O2, that this is water. This is not water. We don't have this. This is not water. H4O2, that's not water. Then it should be something. But if we are referring to a chemical compound that we know, which is water, water should always come in the form H2O. We don't care whatever was mixed. We don't care about the product. We don't care about the reactant. We don't care where the hydrogen is from. We don't care where the oxygen came from to mix. As long as they want to combine and form water, they need to finally give us a ratio of 2:1. That's 2:1. So a chemical compound always contains the same proportion of elements. So the element is hydrogen and oxygen. So water always contains 2:1. We don't have 4:2 or whatever, right? It's 2:1. So hydrogen to oxygen should always be 2:1 when we are referring to water. So water will always be produced, right, in the ratio of 2:1, regardless of wherever the hydrogen comes from, wherever the oxygen comes from. We don't care. As long as the combination will give us water, we are going to have 2:1 combination. So that will be like the same proportion. The proportion will be the same, 2:1. If you have other stuff like CO2 is going to be 1:2. Carbon dioxide is going to be 1:2. There is not going to be 3:6 or whatever. That's how it's work. That's the understanding that we get. Let's look at another law. The law of multiple proportion. The law of multiple proportion, when 2 elements form more than 1 compound. So an example of compound that I will use for this case will be CuO and Cu2O. Right? We have CuO and then Cu2O. So these are the examples that we are going to use basically. And then what will be that ratio? So what are the masses of one element that combine with the face mass of the other element and a simple whole number ratio? So see, here let's assume that in this first combination, the mass of copper that is mixing with the oxygen is let's use an idea of how much should I give the copper? So we are going to keep the oxygen as 1 gram. So 1 gram of oxygen. So in this case, 1 gram of oxygen. So we are keeping the oxygen fixed. And then for the copper is the one varying. So what we are going to do is that we are going to have, like, let's say 2.3, and then this one is going to be let's say 5.3, 5.3 or something like that. So what we are saying is that when two elements form one and one compound, so this is copper and oxygen, and this one to the element that are involved here is still copper and oxygen. But then these two elements, their combination is possible to give us more than one compound. So copper and oxygen can come together to form CuO. Copper and oxygen can come together to form Cu2O. Right? Now, that's what we mean by the two elements form one and one compound. Now, the masses of one element that combine with a, so these are the masses. So I'm varying the copper, CuO. That is combined with a fixed mass of the other. This is fixed mass of the other. So we are keeping 1 gram for oxygen and 1 gram for the oxygen in the second case as well. But then these masses of this one that is varying, these masses are in a simple whole number ratio. So right, it's going to give you, maybe in this case it's going to be 2:5. In other cases it's going to give you 1:3, or depending on whatever you have, right? The mass of one, we are not using this one, this is in grams. We are actually referring to the mass measured in gram, not the number of copper or the number of whatever, right? So basically that's what we mean by them. So if you keep this one as 1 gram, and the other one is going to be missing a simple whole number ratio. If you, the varying one in the two cases in the more than one compound, right? That varying one will be in a ratio of a whole number ratio. That's what we are going to have at the end of the day. Yeah. So these are the three basic one that you need to know. The three that we talk about. There's also law of reciprocal proportion, right? But then for the introductory, right, we are going to talk about these three: law of conservation of mass, which is this one, the law of definite proportion, and the law of multiple proportion. Now, there are other two that we need to add, which is Avogadro's law. Avogadro's law states that at constant temperature and pressure, when the temperature and the pressure are constant, I mean that's the condition, equal volume of all gases contain the same number of molecules. Equal volume of all gases. So if I have a gas, let's say hydrogen gas, right? And then I have, let's say, helium gas or CO2 gas, carbon dioxide gas. So if these three gases are at the same temperature and pressure, are the same, right? If I'm fetching 1 cm cube of each of them, 1 cm cube of this, 1 cm cube of this, 1 cm cube of this, all of them are going to contain the same number of molecules. That's what we mean by this statement, right? At constant temperature and pressure, if you fetch the equal volume of any gas, all the gases, we don't care which element is forming the gas. If the constant temperature and pressure are the same, and you fetch the same volume of each of them, and you count the number of molecules that is inside that volume, all of them are going to have the same number of molecules. That's Avogadro's law. Then we have Gay-Lussac's law. Gay-Lussac's law states that at constant volume, here we are at a constant volume. When the volume is constant, the pressure of a gas is that proportional to its absolute temperature in Kelvin. So you see the previous one, we were making pressure and temperature be a constant K. And then we are varying the volume. We see the volume, we talk about the volume. But here we are keeping the volume constant. So now volume is a constant. Then what we are changing now is, so the pressure is directly proportional to the temperature in Kelvin. So remember, this temperature should not be in degrees Celsius. It should be in Kelvin. That's what we mean. So the pressure of a gas is directly proportional to its absolute temperature in Kelvin, provided we keep the volume constant. So we need to keep the volume constant. That's what Gay-Lussac is also telling us, right? That's about the Gay-Lussac's law. So these are the 5 basic laws that we need to know moving forward. So we're using them mostly when they are needed. So right now, try to get this basic law: Gay-Lussac's law, Avogadro's law, law of multiple proportion. So let me tell you about the so this one was the law of conservation of mass, was given by Lavoisier, right? Antoine Lavoisier. Yeah, this is the scientist behind this law. This is the father of modern chemistry. And the law of definite proportion by Joseph Proust. Let me write it here. Joseph Proust or Proust. Yes. And then this one is the law of multiple proportion. Multiple proportion is by John Dalton. John Dalton. And then finally we have Avogadro's law by Avogadro, and then the Lusas by the Lusa. Yeah. So yeah, let's meet in the next session, and so that we begin to balance chemical reactions. See you there.